All right, let's have a look at solving worded equation problems. Okay, and the focus in this particular lesson is not so much in the solving of the equation, but more in the translation of the worded problem. Okay, so this is an application of using equations in real life to solve real life problems. Let's go through some of these points. So the first point, worded problems need to be translated. Now I've underlined that. That's very, very important. So what we're doing is we're going to be translating a worded problem in plain English and converting it into the language of mathematics, which is algebra, in fact. So worded problems need to be translated into an equation in order to be solved. Okay, so it really is like it's a conversion. Okay, translation conversion. Let's have a look at an example. Okay, so this is example number 1. Okay, there's a few others that we'll look at as well. 11 less than 3 times a number equals 34. Find the value of that number. Okay, now I haven't mentioned which pronumeral to use, and you could make up your own. You could use X if you like, or A, or whichever pronumeral comes to mind. Okay, so for example, I could use the letter M. My name begins with an M, so I'll use the letter M. I could use any pronumeral. So think of a pronumeral, and now we need to start thinking about how we're going to convert or translate this worded, I guess, statement into the language of algebra. Okay, this is the language of mathematics, which is algebra. So 11 less than 3 times a number. So 3 times a number. Okay, according to BidMass, right? This is multiplication. 3 times a number. Okay, so and it's 11 less than that. Okay, so let's use 3m. Okay, and we'll use m as our pronumeral. You can use whatever pronumeral you like. So if your name begins with the letter A, you can use A. Whatever comes to mind. You can even use a shape, triangle or whatever. Okay, so 3m, 11 less than means we're going to take away 11. So that means 11 less than 3 times the number. Okay, so can you see how just with a little bit of algebra, really it takes the place of this entire sentence. Equals 34. Find the value of that number. Now, isn't that amazing that all this English here, all this text can be condensed down to really just a few symbols? You know, and that's really the amazing power of algebra, that it can be used to represent quite a complicated statement if you want to write it down in English, but writing it down in the language of mathematics, you could write it in very condensed form, and you could solve it. You could then find the number, or find the value of that number. This is a 2-step equation, so we'll use 2-step methods to solve this. We'll move the negative 11 over to the other side, so hopefully you still remember how to do this. Okay, leave the 3m alone. The 34 is in the right spot. We're going to move the negative 11 over. It's going to become positive 11. Okay, so all right, 3m is equal to 45, and we're going to divide the 45 by 3. Okay, therefore m is equal to 15. Okay, find the value of that number, therefore m equals 15, and we could leave it at that. Okay, all right, couple more points we'll look at as well. Actually one more point, and a bit of a kind of like a flow chart, really. Okay, so if we're starting off with a worded problem, what we are doing is that we're converting that worded problem into a maths problem in algebra. So what there is here, there's actually a translation going on here. Okay, and this is really the skill that we're focusing on in this lesson. Not so much solving equations. We know how to do that already. Okay, 1-step, 2-step, 3-step equations, equations with pronumerals on both sides, equations with brackets, all that you know how to do. Okay, but when the question is written in plain English, converting that into an equation is the skill that we're focusing on. Maths problem in algebra. Okay, we're going to solve, obviously, that maths problem in algebra, and then we'll give the answer as a worded solution. So whatever the question's about, whatever the context is, whatever the background is, we're going to answer in the same way. So if we're talking about, for example, example 2, we're talking about chickens and a dog, we'll answer in the same way. So let's have a look at example 2. 4 chickens weigh as much as 1 dog and 1 chicken. if the dog weighs 12 kilograms, how much does one chicken weigh? Okay. If you want to pause the video at this point, you can give this a go if you like, and just see if you can come up with an answer for yourself. I'm going to go through the solution, okay, and we'll go through it sort of one step at a time. First thing we need to think of is, well, what do we need to find? We need to find the weight of one chicken. We could let the weight of the chicken be represented by a pronumeral. We could use the pronumeral C for chicken. Okay, so we can say let C equal the mass of one chicken. Okay, so now let's form our equation. It says 4 chickens weigh as much as 1 dog and 1 chicken. Okay, and we know that the dog weighs 12 kilograms. Okay, so 4 chickens, we could represent that as 4C. 4 times chicken, right? 4 chickens, right? 4C. Weighs as much as, which implies that there's an equal sign, 1 dog and 1 chicken. Okay, dog plus chicken. Now we already have a value for the weight of the dog. Okay, so 4C is equal to 12 plus C. This is an equation with the pronumeral on both sides. So the 12's okay, that's on the right hand side. The 4C is fine, that's on the left hand side, but this plus C is in the wrong spot. We're going to move it over, it's going to become a minus C. So 4C minus C is equal to 12. Okay, I've run out of space, so I'm just going to go to this part of the board here. Okay, so 4C minus C, it's going to be 3C, okay, is equal to 12. Okay, C, that 3 times C, we're going to move the 3 over, it's going to become a division, 12 divided by 3, therefore C is equal to 4. Okay, the 1 chicken weighs 4 kilograms. Okay, so the question is about finding the weight of a chicken, so we answer in the same way. This is going back over the flow chart here. We start with a worded problem. Okay, there's our worded problem. We converted it into the language of algebra. Okay, which here's our algebra here. Okay, an equation is just algebra, just with an equal sign. Then in the end, when we solve it, we then answer in the context of the original problem. Okay, so the context of the problem was about chickens and a dog, and the weight of it, we answer in the same way. All right, let's have a look at some more examples. Okay, to make sure that we really do get the hang of this. Okay, let's have a look at an example 3. Okay, find the value of x in this isosceles triangle. All right, what do you know about isosceles triangle? In fact, I've marked them in already. Okay, 2 sides are equal. Okay, so the first thing that comes to mind is, well, I need to know the properties of an isosceles triangle. I know that 2 sides are equal, so that means that whatever this side is, x minus 8, must equal 3x plus 4. So now we can form our equation. And let's do that. So x minus 8, okay, so that's this side here, is equal to 3x minus 4. Okay, I'll give you a moment just to sort of have a think about what we're going to do next. Okay, what sort of an equation is that? That is an equation with the variable or the pronumeral on both sides. Actually, you've got the number on both sides as well. All right, let's solve this then. The x is in the correct spot, right? It's on the left-hand side. The 3x is not. Okay, the 3x should be over the other side. The 3x, when you move it to the other side, it becomes a minus. Okay, so it's going to be x minus 3x. Now, the negative 4, okay, the minus 4, that's in the correct spot. That's fine there. But this negative 8, okay, is in the wrong spot. We've got to move it over. It becomes positive 8. Okay. Now, x minus 3x, like terms, we can combine those, obviously. X minus 3x is negative 2x is equal to negative 4 plus 8. Okay, so negative 4 plus 8 is positive 4. Okay, now we can divide the 4 by negative 2. Okay, it's equal to 4 divided by negative 2. Okay, so this is on the left hand side. This negative 2 is multiplying the x. We can move that multiplication by negative 2 over, and it becomes a division by negative 2. Okay, So therefore x is equal to 4 divided by negative 2 is negative 2. Okay. Example number 4. In 12 years, a person will be 3 times their current age. How old is that person now? Okay, so why don't we let their current age be represented with the letter A for age. So let A be the person's current age. Okay, I'll just squeeze that in there. All right. We need to now form an equation around this pronumeral. So it's saying in 12 years that person will be 3 times their current age. So if their current age is A years, how old will they be in 12 years' time? Well, for example, if you're 13 years old now, in 12 years' time, you'll be 25. So whatever your current age is, just add 12 to it. So if the current age is A, the age in 12 years' time will be A plus 12 years. Yeah, very straightforward. Okay, so that's that. And in 12 years' time, the worded statement states that they'll be 3 times their current age. The current age is A. Okay, again, this is an equation that just has the pronumeral on both sides. The 3A's on the wrong spot and the 12's in the wrong spot there. Okay, so let's move the 3A over. It becomes a negative, so A minus 3A. The positive 12, let's move that over. It becomes a negative 12. A minus 3A, okay, collect the like terms, is negative 2A, is equal to negative 12. Okay. Hopefully you're okay with that. Okay, then we're going to move this multiplication by negative 2 over, and it's going to become a division by negative 2. To be a bit like this problem here, same basic idea. So negative 12, divide that by negative 2, okay? And negative 12 divided by negative 2 is equal to 6. So therefore, the person's current age is 6 years. Okay, so I'll just give you a moment if you want to pause the video, you want to note that down. Okay, please do so. Let's have a look at example 5. This is the last one. Okay, a fundraiser has been set up to raise some money. Each ticket raises $8, but it costs $200 to run the fundraiser. How many tickets need to be sold in order to make a profit of $400? Okay. I should put a question mark at the end of that. It is a question. All right. Have a think about that for a moment. How would we do this? Okay. So what would you use as a pronumeral? Okay. Again, you could use the letter X if you like. If you can't think of any other pronumeral. Okay. So in other words, we need to sell some tickets. Okay. Obviously, each ticket makes $8, but we need to spend $200 all up to run the fundraiser. Okay, but we need to make a profit of $400. Okay, so every ticket sold, let's use the letter T. Let T be the amount of money made. Okay, you know what? Let's change it slightly. Okay, because let T be the number of tickets sold. That's probably better. Actually, number of tickets sold. Yeah, no, I like that better. Okay, because really what we want to find is we want to find the number of tickets. Okay. So I think it's most appropriate then that let's let the pronumeral T then be the number of tickets sold. Okay, well, I'm happy with that. Where to from here? So now the amount of money made all right, from ticket sales is then how much? Right? You sell T tickets, each ticket makes $8. It's going to be T times 8, which equals $8T. But this fundraiser is not free to run. How much does this fundraiser cost to run? Right, it costs $200. But we want to make a profit of $400 though. So in other words, we sell some tickets, we're going to take away $200, but we still want to end up with $400 in the end. Okay? So in other words, we can form an equation, 8T, that's the amount of money made from the ticket sales, minus the $200 that it costs to run the fundraiser, and we're going to make $400. Okay, this is just a basic two-step equation. Let's move the negative 200 over to the other side. Okay, 8T is equal to 400 plus 200, okay, which is going to be 600. In fact, what I'll show you I'll show you the actual step itself. Okay, so the minus 200, when you move it over, it becomes a positive 200. Okay, 8T is equal to $600. Okay, 8T, that's 8 times T. We want to move the 8 over, it becomes a division. 600 divided by 8. Okay, what's 600 divided by 8? Okay, put in your calculator. Therefore, T is equal to 75. So, what does that mean? What does the T equals 75 mean? Well, go back to what we defined T to be. T is the number of tickets sold. So, therefore, 75 tickets need to be sold to make a profit of $400. And that's how we solve worded equation problems.